Hey guys, it's Miss Meneely, and I'm going to give you a brief tutorial to help you review for your Quarter 1 assessment in Algebra 2. In Quarter 1, we've essentially covered two different units. We've talked about systems of equations, and we've talked about quadratic functions. With systems of equations, we've dealt with both 2 and 3 variable systems. With quadratics, we've graphed. We've talked about factoring quadratics to find real solutions. And then we've also talked about using the discriminant and the quadratic formula to solve quadratics to find the imaginary solutions or complex solutions. We've also talked about operations with complex numbers. So there are 9 problems on the review guide, and what I've done is I've separated them per topic, and I've rearranged the order that I'm going to be going through the tutorial. So I'm actually going to do 5 short videos to cover each topic, and so we're going to sort of skip around the review guide. Notice that 8 and 9 are written in blue, and that's because they correspond to the calculator problems on the quarterly assessment. So most of the assessment you are to do without a calculator, but the whole thing can actually be done without a calculator. But the last 2 problems you're allowed to use a calculator, and so I'll show you how to do that then. So the first tutorial that I'm going to go through has to do with systems of equations. And like I said, we've talked about 2 different types of systems. We've talked about systems that involve 2 equations and 2 variables. We've also talked about equations or systems that involve 3 variables and 3 equations. When your systems are written in standard form, like these 2 equations are, the easiest method to use is the linear combination, or it's sometimes referred to as the elimination method. And that's essentially because we modify one or both of the equations so that we can combine them with the purpose of eliminating one of the variables. And when we eliminate one of the variables, then we've isolated the other variable and can solve the system. So if this is the system I'm looking at, 3x minus 4y equals negative 18 and 2x plus 8y equals 52, I need to choose which variable I want to eliminate. So if I focus on the x variable, I've got to think about a number that both 3 and 2 divide evenly into. So it's going to be a number that's bigger than those 2 numbers. And if I think about it, 6 would be the number that I would choose. Both 3 and 2 divide evenly into 6. But I would have to change both equations to make that happen. Instead, if I look at my y variable, one of the coefficients is a negative 4 and the other is a positive 8. Since 4 divides evenly into 8, I only have to change one equation to make my y's cancel. And so if I multiply my first equation by a 2, that's going to give me a coefficient for y of negative 8. And a negative 8 is going to cancel with a positive 8. So remember that your coefficients have to have the same number, but they also have to have opposite signs so that when you combine them, they cancel. Now, if I'm going to transform this equation, I do have to remember to distribute the 2 to each term. And so if I do that, I'm going to end up with 6x minus 8y equals negative 36. The second equation I don't need to modify, so I'm just going to rewrite it as 2x plus 8y equals 52. Now if you think you've got it from here, go ahead and press pause and solve the rest of the system yourself. If you still need a hand, then keep watching. Okay, now that I've modified my first equation, I can see that my y variable is going to be eliminated. Now I can add my x's together, and I'm going to have an 8x, and that's going to equal 16. If I divide both sides by 8, I learn that x is equal to 2. If you think you've got it from here, press pause and finish up the problem. Otherwise, keep watching. Now with what I know about x, I can plug that value into either one of the equations. So let's go ahead and plug it into the first one. It's a 3 times x, and I'm just going to use parentheses to hold the place, minus 4y is equal to negative 18. If I substitute in what I know about x, which is 2, and then continue solving, I'm going to have 6 minus 4y equals negative 18. I need to move the 6 to the other side. Even though this is a subtraction problem, remember the 6 is positive. So in order to move it to the other side, I need to combine it with a negative 6. Now my 6's cancel, but I still have a negative 4y, and that's now going to be equal to a negative 24. And if I divide both sides by a negative 4, I learned that y is equal to 6. So that means that my system does have a solution. That means it's a consistent system. It's also an independent system because it has one solution. And so if I look at my answer choices, I know I can eliminate D or C and D. And if I take a look at A and B, both of those identify one solution, In letter A, it says x is 0, and in letter B, it says y is 6, and that is the one that is correct. We know that it's consistent because there's one solution, and the solution occurs when y is equal to 6. Okay, we're going to jump all the way to problem number 9. Problem number 9 is in the calculator section, so you're allowed to use a calculator here. There are 3 parts to number 9, and all of them involve words. So number 9 in part A says the Johnson and Spiegel families went to the movies Friday night. Mr. Johnson bought 2 adult tickets and 4 children's tickets for a total cost of $60. Mrs. Spiegel purchased 3 adult tickets and 2 children's tickets for $54. Determine the cost of an adult and a children's ticket. So we have to, before we do anything, we have to set up an equation or a system of equations to represent this situation. And since I'm going to be using variables, I want to make sure that I define my variables. And so if I think about it, I'm trying to find the cost of an adult ticket and the cost of a child's ticket. So I'm going to let x represent the cost for an adult, and I'm going to let y represent the cost of a child. Okay. And this is a multi-point problem, so you do want to make sure that you show all your work, that you define your variables, and then ultimately when you've solved the system, that you write your answer in the context of the problem. So if it starts in words, your problem should end in words. Now I'm going to go ahead and set up the system. So I know I have 2 individuals that made purchases. I know that Mr. Johnson bought 2 adult tickets, so that means that he bought 2x, and he also bought 4 children's tickets, which would be a total of 4y, and he spent $60. Ms. Spiegel purchased 3 adult tickets, that would be 3x, and 2 children's tickets, plus 2y, and she spent $54. And again, because both of my equations are in standard form, I'm going to look to see which variable is the easiest to eliminate. When I look at my x's, 2 and 3, both go into 6, but I would have to change both equations to make that happen. If I look at my y's, since 2 goes into 4, I can just adjust my second equation to make my y's cancel. And if I have a positive 4y, in order to cancel that, I need a negative 4y. So I want to think about what do I need to multiply my 2y by to get negative 4y, and that's going to be a negative 2. So now I'm going to multiply through. My first equation is going to stay the same. My second equation I'm going to multiply through. Negative 6x minus 4y, and if I multiply negative 2 times 54, that's going to be a negative 108. And this is a calculator problem, so if you need to, you can certainly use your calculator to do that multiplication. Now we're going to go ahead and combine. And if at this point you think you know what to do, go ahead and press pause and solve the rest of the problem. Otherwise, go ahead and keep watching. When I combine the 2 equations, I'm going to end up with negative 4x is equal to a negative 48. And when I divide both sides by negative 4, I'm going to have that x is equal to 12. And let's just go ahead and put this in context. We said x represents the cost of an adult ticket. So I know that $12 is the cost for adults. To solve the rest of this system, I need to plug that 12 in for my x variable in one of the other equations. And again, if you know what to do, go ahead and press pause and finish out the problem. I'm going to go ahead and plug the x into the first equation. So we'll have 2 times x, I'm just going to use parentheses to hold my spot, plus 4y is equal to 60. Now go ahead and plug the 12 in for x. 2 times 12 is 24, plus 4y equals 60. I'm going to subtract 24 from both sides. And that gives me 4y equals 36. If I divide both sides by 4, I find that y is equal to 9. And again, let's put that in the context of the problem and say that $9 is the cost of a child. Okay? In part B, I'm going to read the problem, and then if you think you got it, I want you to go ahead and press pause and set the system up all by yourself. While at the movies, Mr. Johnson purchased 2 large tubs of popcorn, 4 drinks, and 1 box of candy for $31. Mrs. Spiegel purchased 1 large tub of popcorn, 2 drinks, and 2 boxes of candy for $20. Jake, a friend of both families, purchased a drink and a box of candy for $7. Determine the cost of each: a large tub of popcorn, 1 drink, and a box of candy. So if you think you can set it up, go ahead and press pause right now. Otherwise, keep watching. Okay, the first thing we need to do is define our variables. So I'm going to go ahead and let x represent the cost of the popcorn. I'm going to let y represent the cost of a drink. And I'm going to let z represent the cost of a box of candy. All right, and now I'm going to go ahead and write my equations. So Mr. Johnson purchased 2 large tubs of popcorn, that's 2x, 4 drinks, that's 4y, and 1 box of candy, that's 1z, and he spent $31. Ms. Spiegel purchased 1 tub of popcorn, that's 1x, plus 2 drinks, that's 2y, and 2 boxes of candy, that's going to be 2z, and she spent $20. And finally, Jake, a friend of both families, purchased a drink and a box of candy. So he didn't purchase any popcorn, so there's no X's, but he did purchase a drink, so that's going to be 1Y, and a box of candy, plus 1Z, and that is equal to $7. Okay. So now that we have a system of equations, notice that we're kind of cut a break here with that third equation only having 2 variables in it. That kind of helps me to figure out what my first step should be. Since I already have one equation that involves just a y and a z, in order to solve for those variables, I need another equation with just a y and a z. So what I'm going to do is I'm going to combine my first 2 equations, and which variable do I want to eliminate if I want to be left with y and z? I want to eliminate x. Okay, and so when I set this up, I'm going to think about, well, what numbers, since I'm looking now at the coefficients of x, what numbers do both 1 and 2 go into evenly? Well, both of them go into 2. So all I need to do is take my second equation and multiply by a -2, and that way my x's will cancel. So my first equation is going to remain the same. I'm going to have 2x plus 4y plus 1z, and you don't need to put a 1 in front of it. And that equals 31. Now when I change my second equation, I'm going to have a -2x minus 4y minus 4z equals, and don't forget you have to distribute it all the way to the other side as well, that's going to give me a -40. Well, look what happens when I do this. Not only does my x cancel, but my y's cancel too, which is actually kind of convenient. And now I find that I'm going to have, when I combine my z's, I have a -3z, and 31 minus 40 leaves me with a -9. And that's actually pretty cool, because now if I divide both sides by -3, I actually have a value for one of my variables. I know the value of z. And remember, let's go ahead and just put this back into the context of the problem. 3 corresponds to the cost of candy. So it's $3 for a box of candy. And now that I know that, which equation do I want to plug that into? Why don't you press pause and try figuring out the rest of the solution on your own? Otherwise, keep watching. Once I know the value of z, I'm going to want to plug it into the equation that has only one other variable. And so when I do that, I'll have 1y plus 1 times z, and I'm just going to put parentheses there, and that's equal to 7. If I plug in what I know about z, that it's $3, then essentially I have 1y plus 3 is equal to 7. And if I solve for y, I'm going to get that 1y, or simply y, is equal to 4. And again, I'm going to put that back into the context of the problem. That means that $4 is the cost of a drink. And now I'm almost done. If I know the cost for candy and I know the cost for a drink, I'm going to plug the values for z and y back into either one of those first 2 equations to figure out the value of x. And I'm sort of running out of space here, so I'm going to actually do this up here. So I know that 2x plus 4y plus 1z, oops, let me put parentheses there, is equal to 31. Well, I know that y is 4 and z is 3. And so when I simplify this, I'm ultimately going to have, I'm going to put this up here, 2x. So 4 times 4 is 16, and 1 times 3 is 3. 16 plus 3 is going to give me 19. So I know 2x plus 19 is equal to 31. If I subtract 19 from both sides, I get, should be a 19, I get that 2x is equal to 12. And so if I divide both sides by 2, I get that x is equal to 6. And that's going to be $6 for a box or a tub of popcorn. Okay, so we started with words and then we ended with words. Make sure that each of your solutions goes back to the context of the problem. And again, this is a multi-point problem, so you want to make sure you define your variables. In the last question, you're given a system, and notice this time your system involves 4 variables, w, x, y, and z. And the question is it possible to solve this system, why or why not? And one of the things you need to remember is that we need to have the same number of equations as we have variables in order to find a solution. And so because we have more variables than equations, this system cannot be solved. Oops, more variables than equations is what I meant to say. Okay, so I have to have at least as many equations as I have variables in order to find a solution. All right, so that wraps up the tutorial on solving systems of equations. Whether they're 2 variable or 3 variable, we're going to follow the same approach using the linear combination, or sometimes it's referred to as the elimination method.